In this tutorial, we're going to be talking about the Dalton's law of partial pressure. It says if you have in a container, let's suppose I got this container right here, and if it has multiple gases in there, and I could have something like N2, O2, and maybe argon in there, then the total pressure that's going to be inside of that container is actually going to be equal to the sum of the partial pressure of all these gases. So the pressure coming from the nitrogen, the pressure coming from the O2, and the pressure coming from the argon. And if you have, let's say, another gas, then you would add up the pressure of that gas as well to get the total pressure. So the questions that are actually related to the Dalton's law are fairly simple. The only catch in those is you may very well be given the partial pressures of different gases in different units. And if that's the case, you want to make sure you convert all the units into the same unit before you add up the pressure. Okay, and then in addition to that, I also want to mention if you're given the total pressure, then you can figure out the partial pressure of the gas by using the mole fraction as well. So another way of saying, if I want to calculate the partial pressure of nitrogen, I can say the mole fraction of nitrogen times the total pressure would do the job there. Well, if you forget what a mole fraction is, your mole fraction is going to be equal to the moles of nitrogen divided by the total moles, which means you would add up the moles of nitrogen plus the moles of oxygen plus the moles of argon. So I can probably just write that down here. Your total moles would be equal to the moles of nitrogen plus moles of argon and plus moles of O2. And obviously, these are the only three gases we're considering here. If you have more gases, then you would add up the moles of that gas as well to get the total mole. Now, if you want to figure out the partial pressure of O2, you would use a very similar formula where you would have the mole fraction of O2 times the total pressure. So sometimes that happens as well, where they give you the moles of the gases and they will have the total pressure given. And in that case, you can figure out the partial pressures by just figuring out the mole fraction first and multiplying the mole fraction with the total pressure. Okay, well, let's look at this problem right here. It says a mixture of gases, we got N2, O2, and argon, has a total pressure. Okay, so I'm given the total pressure, so I'll go and write that down here. So your P total is 960 mm of mercury. If the partial pressure of N2 and O2, so the partial pressure of N2 to be given 220 torch, and the partial pressure of O2 is given to be 0.55 atmosphere. And we got to figure out the partial pressure of the argon. Okay, so to figure out the partial pressure of this argon, I can set up my equation where I would say the total pressure, so PT, should be equal to the pressure coming from the nitrogen, the pressure coming from the oxygen, and the pressure coming from the argon. And it seems like I know the total pressure and I know the nitrogen pressure, also know the oxygen pressure. I should be easily able to calculate the argon pressure. The only problem here is they're all in different units, so make sure you actually get everyone in the same unit. And in this case, it doesn't really ask what unit you want for the argon, so you can just pick any one of those units to be your base unit or common unit here. And I'll go with the atmosphere because that's the most common units of pressure going to be used in chemistry. So let's go ahead and calculate this 960 mm of mercury into the atmosphere first. So what's the conversion factor there? Well, remember, 1 atmosphere is going to be equal to 760 mm of mercury. So the mercury, mercury cancels out, and then you are left out with 960 divided by 760, so that's going to be 1.26 rather, atmosphere. Okay, and I want to do the same thing with the pressure of nitrogen, which is 220 torrs, and change that 220 torrs into the atmosphere. And remember, 1 atmosphere is also equal to 760 torrs. Okay, so let's do that math now. So 220 divided by 760 is going to give you 0.29 atmosphere. Okay, so seems like we got everything under control here. I'll go ahead and plug these numbers in there, or I can just go ahead and rearrange this where the pressure of argon is going to be equal to the total pressure minus, I got this pressure of nitrogen plus the pressure of oxygen. Or you can just go ahead and plug the numbers in the original equation and solve the pressure of argon. You can do the math however you really want. So the total pressure is 1.26 minus the pressure of nitrogen comes out to be 0.29, and then the pressure of oxygen was given to be 0.55. Okay, so when you do this math here, so add up the pressures and subtract it from 1.26, so 0.29 plus 0.55 and subtract that from 1.26 is going to be 0.42 atmosphere as your final answer. That's going to be the pressure for the argon. So you could have a very simple question related to the Dalton's law of partial pressure, but just make sure you have the right units when you're adding the pressures or subtracting the pressures in the equation. Okay, hopefully this video is helpful. If you have any questions, feel free to leave the comments in the section.